Welcome back, friends. We are building the Fractals and Recursion program from the YByte Python curriculum available at www.ybyte.in. We are just getting started. So I have created a simple turtle program. I imported turtle. I created a turtle, which I can see here. And thereafter, I wrote a function to just draw me a square. Now, this is something we have done before. For example, in Paint with Turtle, for example, also in the pixel art. So I'm not going too detailed into this, but basically function is quite straightforward. I just go to every X and Y position and, knowing the length of the square, I just draw it. Of course, you can use any other function to draw a square or any shape that you want to. But basically, once I call this function, let's say, say at 0, 0, and 100. Now, which means that at 0, 0, which is X, 0, Y, 0, L being 100, I want to draw a square of, let's say, a side of, say, 100 units. When I do this, predictably, my, turtle draws a square. So there's nothing, let's say, unusual about this, nothing new about this. But now let's give this function a little bit of a twist. I just put a small comment here, say recursive call. Let me just put this correctly. So recursive call, and all I do is that I say that, look, if L is greater than 10. Now 10 is just a number. We will talk about this later. If L is greater than 10, then go and call square again. This time round at X plus L, Y plus L, and let's say L by 2. Now remember, this is a case of function calling itself. Notice I'm calling the function square inside the function square. So this is clearly recursion. I am going to call this function with a different X and Y position and a lower, let's say, L. So when I give, let's say, for example, L of 100, I will call this function with L of 50, then 25, then 12.5, and so on. So I'm saying that, look, till the time L is more than 10, keep calling this function. Now it's very, very interesting to see what happens when I now run this function. So when I, run this, remember, I'm giving the same square 0, 0, 100, but see what ends up happening. I end up getting not 1, but in fact 5 squares. And this is like our first recursion ended up with 5 squares. Now this happened because this function was calling itself, but we will see this in a lot more detail in the next video. But before wrapping this up, let me just run you through the structure of this a little bit more carefully. So notice I had, the function square. Now inside this, I've called this function at X plus L, Y plus L, and L by 2. From the command line, I give a command 0, 0, 100. That's why my next square gets drawn at, let's say, X plus L, which is 100, 100, and of square length 50. Next square gets drawn over here, next square here. But notice every subsequent square is becoming smaller and smaller. This code is structured basically in a way that there is a part of the code which draws the square. Then there is this thing called the base case. Now base case is like the, the stopping case where the recursion stops. And this is absolutely a must in a recursive program. Now let's say I did not have this L greater than 10. Well, in that case, basically I've created an infinite loop where the function is calling itself infinitely, even though L is becoming smaller and smaller. Now, this will cause a problem because we'll end up in an infinite recursion depth, which is most of the times not allowed. So, you will end up in an error. So while fractals are technically infinite, but here we are limiting it to a finite situation so that the code can stop. And this is absolutely a must in every recursion. Every practical recursion. Notice that in every iteration, the L keeps reducing, and that's why the squares keep on becoming smaller and smaller. At some point, L becomes less than 10, and that is when the recursion stops. So the code to draw the square happens, and recursion stops. We sort of get out of it. Now, we are going to take a much deeper look at this so that we understand what's going on. But I hope this is giving you a flavor of what recursion looks like. Remember, recursion is basically a function calling itself, but we must have a condition which stops the recursion. This is called the base case. This must be done. Otherwise, we are in trouble. I hope this was useful. In general, this is another example of the YByte's unique methodology where we are applying concepts, getting into the depth of them by building interesting projects. Do look at our website to get more ideas. We have many, many, many such projects. Take care. Thank you so much. Bye-bye.